Welcome to Intermediate Algebra, Unit 7, Lesson 2. We're going to add and subtract rational expressions. Now remember, a rational expression is one that's basically a fraction. So the lesson objectives are to add rational expressions with like and unlike denominators. It's fairly easy with like denominators. For unlike denominators, you have to turn them into like denominators first. And then we're going to do the same with subtraction. There is one more place that students typically make mistakes if the fraction you're subtracting has more than one term on the top. So we'll take a look at that. So first, to remind you how we add and subtract fractions, adding and subtracting, it can be more complicated than multiplying or dividing fractions because you need a common denominator. I can't take some number of halves and add them to some number of fifths and get any answer that makes any sense. It's easier to turn the halves and the fifths into a proportion that has the same denominator. So I can write 1/2 in another form that's equivalent, but in 3/5 another form that's equivalent, and choose a form such that both of them will have the same denominator. You've seen this before, and you're probably wondering why I'm explaining it so much, but students often forget the basic principles. So you find a common denominator, and we say the least common denominator. When all your denominators are prime, multiplying them together does give you the least common denominator. But even if they weren't, you can use a common denominator that's not least and reduce at the end. So you can always find a common denominator by multiplying the two denominators together, or if there's more than two fractions, the three denominators together. In our case, the common denominator will be 10 because 2 goes into 10 and 5 goes into 10. So in order to write 1/2 as some number of tenths, I would have to multiply the 2 times a 5 to turn the bottom into a 10. So I also have to multiply the 1 times a 5 because when I do that, I'm really multiplying the 1/2 by a value of 1. 5 divided by 5 is 1. So I'm not changing the value. So that will make that first term 5/10. 1 times 5, 2 times 5. And then I'm going to add, I need to turn 3/5 into tenths in order to turn the 5 on the bottom into a 10, and that's what you look at the bottom. You have to multiply it by 2. So you also have to multiply the top by 2 to keep the value of the 3/5 fraction the same. So you get 6/10, and if you took a circle and colored 6/10 of it, you would have the same area colored as if you colored 3/5 of it. If you colored 5/10 of a circle, it would be 1/2 of it covered. So now I have the denominators the same. I can just add the numerators and leave the denominator as it is. So I get 5 plus 6 over 10, 11/10. We use this same process when we have algebraic expressions with letters in them. So for subtraction, you'd use exactly the same process. If this were a subtraction sign, it would just change right here. This would be 5 minus 6, that'd be a minus, that'd be a minus, and I would get -1/10. So here's an example with algebraic expressions. So this one, the denominators are already the same, so I simply perform whatever operation in the middle here is on the numerators. So I'm going to add the numerators. And when I add 4x squared to 2xy minus y squared, there's no like terms, so I get a 4x squared. I have a -5xy plus a 2xy gives me a -3xy. And then there was no like term with the y squared, so it's just -y squared. And then I would need to do the next step of looking, after I combine the numerators, I would want to see if I could factor the top and the bottom and reduce to simplify. That is one additional step you have to do after you add or subtract. In this case, it does simplify because the top and the bottom, when you factor them, each have a factor of x minus y. So you try this one. Add the denominators. Keep the denominators are the same. Add the numerators and factor and reduce if you can. So stop the video and try it and then come back. Okay, you're back. I'm trusting you tried it. If you're just flying through this, it's not going to be as helpful. So this addition problem simply becomes addition of the numerators because the denominators are already like. And I do 2x squared plus x squared. I get 3x squared, negative 5x minus 19x, negative 24x, 9, 4, plus 4 is 13. So I get 3x squared minus 24x plus 13, which does not seem to factor. I couldn't find a way to find the factors of 39. That added up to negative 24, so it won't factor. So this is the solution. Alright, now subtracting with denominators that are already the same. You say, well, it's going to be the same thing. We have to be careful here, because remember, what we don't tell you enough is that this fraction bar that you see in each of these terms that are subtracted implies that there's parentheses around the top, parentheses around the bottom. It is a grouping symbol. It says everything on the top happens first, and then everything on the bottom simplifies before you do this division. They are grouped together. So this x minus 2 really needs parentheses around it. So when you do the subtraction, you need to put those parentheses around it, otherwise you're going to have a sign error in every term except the first one you subtract. So I get 4x plus 5 minus the whole thing, x minus 2. So that's like distributing a negative 1. It's like adding a negative x and a positive 2. You change all the sign. When there's a negative outside parentheses, it changes the sign of each term in the parentheses. So the x was positive in the parentheses, it becomes subtracted x outside. It was minus 2 in the parentheses, it becomes adding 2 when you remove the parentheses. Now you should be able to get a correct answer by grouping like terms. 4x minus x is 3x, 5 plus 2 is 7. The denominator started out the same, so you just write the denominator in the end. That is the denominator of your answer. You don't add the denominators or subtract the denominators. You make them the same. If they're already the same, you can skip that step. But that becomes the denominator after you combine the numerators. It stays at x plus 3. So try this one, and notice the denominators are the same, so the process is similar. And then stop the video and come back and look at the answer. Okay, you're back. Here we go. Again, we have to be careful to put parentheses. Here I put parentheses around everything just to be clear. If I didn't put them around the first numerator, it would be okay, but I have to have them here. So you would be wise every time you have one of these problems. If the denominator is the same, you don't have to worry about that, but put parentheses around the tops and bottoms and then write this out. Now, a negative in front of the parentheses takes that positive 3y and turns it into a subtracted 3y. The subtracted 5 inside becomes an added 5 when you remove the parentheses. Combining like terms, I get y plus 12, and this does not reduce at all, and nothing else factors. So it becomes more complicated when there's not already a common denominator, because you have to make the problem into one with a common denominator first. So to find the least common denominator of a set of algebraic fractions, you factor each denominator into prime factors. That's no different than when you do it with numbers. List all of the different prime factors, and the least common denominator will be these factors multiplied together, but each factor has to show up the maximum number of times it shows up in any individual fraction. In other words, if you had an x plus 1 on the bottom of one fraction and an x plus 1 squared on the bottom of another, you would need to use the x plus 1 squared. So here I factor, I'm just finding the least common denominator here. I'm not going to finish the problem out. I'm just looking for the least common denominator between these two fractions. I factor the x squared plus 5x plus 4. I factor the x squared plus 2x plus 1. I see I have an x plus 1 occurs twice in the second fraction, so I will need x plus 1 to occur twice in my least common denominator. I have an x plus 1 once here, but it's already going to occur twice for that, so I can ignore that one. So I get x plus 4 times x plus 1 times x plus 1, which shorthand for that is just x plus 1 squared. That would be my least common denominator. The first fraction would be missing one of the x plus 1's, so I would multiply top and bottom by x plus 1. The second fraction would be missing the x plus 4, so if I were turning these into a least common denominator, I would multiply top and bottom by x plus 4. So let's do an addition or subtraction problem that uses this in a moment. So you try this. Just simply find the least common denominator. Don't do anything with it, but find the least common denominator. Stop the video and return when you're done. Okay, so you're back. Here we go. The first fraction had x plus 6 times x plus 1. The second one had x plus 4 squared. So I need an x plus 4 squared. It occurs twice in one of the fractions, so it has to occur twice in the common denominator. Simply x plus 6 times x plus 1 times x plus 4 squared is my least common denominator. Now some of you might be thinking, couldn't I have just multiplied this whole thing by this whole thing? Yes, but you're better off factoring before you do that, because that, if you did have to add or subtract these, that would help you figure out which fraction needed what factor added to its denominator. So here's an addition problem with the denominators are different. The first denominator is x plus 2, that's already completely factored. The second denominator is x plus 2 times x minus 2. So x plus 2 times x minus 2 is my common denominator. I don't need the x plus 2 twice, because in any individual fraction it only occurs to an exponent of 1 in the denominator. So I can use x plus 2 times x minus 2, and x plus 2 from the other fraction is a factor of that. So the first fraction is missing the x minus 2. So I multiply top and bottom by x minus 2. The second fraction has the common denominator on the bottom already, so I leave that alone. When I distribute the negative 2 to the x minus 2, I get negative 2x plus 4 here, and I'm going to add x plus 3 to that. That's not as dangerous as subtracting, because I don't have to worry about sign changes over here. So then I get negative 2x plus x is x, 4 plus 3 is 7. That and the denominator have no common factors, so I am done. So now you try this one. Find the common denominator, write the fractions over their common denominators by making the adjustments you need, and then add. Stop the video and come back. Okay, you're back. So x minus 2 times x plus 1 times x minus 1. Now note, this x plus 1 and this x plus 1 were in different fractions on the bottom, so I only need an x plus 1 once. If I were to just multiply these two denominators together, I would have had an x plus 1 squared, and at the end I would have had to reduce by an x plus 1. But I see x plus minus 2 times x plus 1. I already got an x plus 1, and that's the only one there is, x minus 1. There's my common denominator. The first fraction is missing the x minus 1 in the bottom, so I multiply top and bottom by that. The second fraction is missing the x minus 2, so I multiply top and bottom by that. You need these parentheses everywhere. So I multiplied the first numerator together. This is the only time with rational expressions you really do multiply things out, is you want to simplify the numerator to see if it factors and has anything in common with the denominator when you're done. So I multiply x plus 3 times x plus 1, and I get that. I multiply 2 times x minus 2, and I get 2x minus 4. And now I can just add the tops because the bottoms are common. And I get x squared. The 2x and the 2x gives me 4x. Negative 3 plus a negative 4 gives me negative 7. This does not factor, and it certainly doesn't factor using any of these, so even if it did, if it didn't use any of the factors on the bottom, it would not reduce. So here's a subtraction one. Again, common denominator, you find it's x minus 4 times x minus 2 times x plus 3. The first one's missing the x plus 3, the second one's missing the x minus 2. Now I have to be careful here because I'm subtracting, so I really want to make sure this is in parentheses. So that negative becomes subtraction up here. You could change this to addition and do a negative in front of the second numerator if you wanted. that might make it easier for you. Some students do that. They turn subtraction into addition of the negative, and to make a fraction negative, you just negate its numerator. So you could negate the denominator, just negate the numerator. You one or the other, but not both. But negate the numerator because you want the denominators to stay common. So I multiply out the 5x times the x plus 3, I get 5x squared plus 15x. And I distribute this negative 3x. You could think of this as plus a negative 3x distributed. So I get negative 3x times x is negative 3x squared. Negative 3x times negative 2 is plus 6x. Combine like terms. And if an x does factor out of the top here, but there's no factor of x on the bottom, so it won't allow us to reduce anyway. So you can just leave that as it is. Alright, you try this subtraction one. Be careful of the distributing that negative sign. If you're having trouble coming up with a way that works consistently, get some help with that, and we'll figure out which way, doing a plus, putting parentheses around this, and turning that into a negative. As long as you put parentheses around it, you can do that. Or if there's another way that works better for you. So try this one and then come back. Alright, so I assume you stopped the video and tried it, and now you're back. The least common denominator turned out to be x minus 1 times x plus 3 times x minus 3. The first fraction's missing the x minus 3 on the bottom, so I multiply top and bottom. The second fraction was missing the x minus 1. So I multiply out each of the numerators. 3x minus 1 times x minus 3, put it here. X plus 4 times x minus 1, write that over the denominator. Now I do my subtraction. You're going to change each of these signs. You can see I did that here. Now I group like terms. I get 2x squared minus 13x plus 7, which I actually don't know if I tried to factor that one. I don't think any of these came out of it, but you could check that. That may simplify, but I don't think it does. Alright, so if you got that simplified, let me know. I'll take a look at it meanwhile. Alright. That's the end. So I wasn't as concerned about the simplification here. I should have checked that better and factored the top if it could be factored, because 2 times 7 is 14. There's no way to get a positive 14 factors to add up to negative 13, so I'm pretty sure it doesn't factor. Anyway, thank you for watching this lesson on adding and subtracting rational expressions.